Hello everyone, this is Mr. McMillan. I'm here with the instructional video on surface area and volume of composite 3D figures. And what we're going to look at today is all of these composite figures. And all a composite figure is an object made up of multiple three-dimensional objects. So we've talked in the past about three-dimensional objects, and we talked about how to find the surface area of them, the lateral area if they have one, the volume, and so on and so forth. Today we're going to be putting those together. So for instance, if you put together a cylinder and a cone, you have made a composite object. You put them flush against one another, and they sit on top of one another just like this. Okay, so that would be a composite object. And as you can notice here, if I have the cylinders and the cone, I put them flush together on their base. So this is no longer part of the object itself. Instead, this is just one conjoined thing. Okay, so they join together at the base to form those composite objects. Okay, so you may have a base for one thing on another base or another face or whatever else. Okay, so common composite three-dimensional objects include objects made from cones and cylinders, just like you saw there. Hemispheres and cylinders or cones. And the thing about a hemisphere, you've talked about this in your science classes, and when you're talking about the Earth has two different hemispheres. You've got the northern hemisphere and your southern hemisphere, and each one of those is where it splits the Earth directly in half. So that's what a hemisphere is. A hemisphere is half of a sphere. Okay. So that means if you wanted to find the volume or surface area of a hemisphere, the volume of a hemisphere would be half of a sphere's, and the surface area of one would be half of the sphere's surface area as well. So that's just something to keep in mind, and although it's not on this note sheet specifically, I will make sure to show you how to do that in just a minute. So how do we determine the surface area and volume of a composite 3D objects? Well, the first one we're going to talk about is volume, and volume is the simplest one. Okay, so if you're just putting two objects or more objects together, the first thing you want to do is identify the three-dimensional objects that are used. So for instance here, if you have this figure here, you're going to be using the formulas for a cylinder and a cone, right? Because that's the two things that you're using. So after you determine what objects you're using, what 3D objects you have, you're going to find their volume using their respective formulas. And then because you have put these together, and when you put two things together, you have joined them together, you've added them to each other, you're going to find the sum of the volumes of the three-dimensional objects used in the composite object. So for this figure that I've been showing you, once you find the volume of the cone and the cylinder, you will find the total volume by adding them together. So that's what you would do. Okay. Now surface area is a bit more complex in most cases. So to determine the surface area of a composite 3D object, first off, you have to identify the three-dimensional object that are used. So there will be at least two, but could have more. So you know, here again, you would have the cone and the cylinder for the other thing, but there's a bunch of other shapes that fit together. Now, unlike the volume part where you can just find the volume and be consistent, this you need to find the lateral area of each 3D object that's used in the figure. So not all shapes will have this. So in that case, you'll just use the appropriate surface area formula. So for instance, a sphere does not have a lateral area because it has no base. So you would just use the surface area of a sphere to find that one. And likewise for a hemisphere. Then of course, when you want to find the total surface area, you find the sum of the areas of the three-dimensional objects used in the composite object. This will be your answer. So if you have a lateral area of a cone and a lateral area of a cylinder, and you have those two shapes together, you would add them up. So before we move on to some example problems, I'm going to show you how to determine the volume or surface area for a hemisphere. So of course, with a normal sphere, you have it like this. You know, you've got your hemisphere here, or you've got your sphere, and it has a radius. Well, what you're doing with a hemisphere is you're taking that and you're doing half of it. Okay, but you still have the same radius as you did the sphere. So you treat it as if it's a sphere. So for example, if my radius is 4, what I'm going to do there, I'm going to use the volume formula, 4/3 pi r cubed, to find the volume of the total sphere if the radius was 4. So when I do that, I get 4/3 times pi times 4 cubed. And 4/3, or 4 cubed, excuse me, is 64. Okay, and we're going to type this in the our calculator because it's easier. So 4/3 times 4 cubed. And we're going to go ahead and type in pi there as well. So we get 268.08 for our volume. But that's the volume of the entire sphere, right? We want to find the volume of the hemisphere. So for the hemisphere volume, you would take 268.08, divide it by 2 to give you 134.04. Okay, and you would do surface area the exact same way, just with its own formula, 4 pi r squared. Okay, so if you do run into a hemisphere, which you will on the worksheet, then this is how you find the volume and or the surface area. So let's look at some examples. So we're going to look at one here, and we're going to find the surface area for this one. Okay, so our first step in any of these problems is we need to determine what 3D objects we're looking at. And if you look at this figure, it sort of looks like the figure that I had, or at least part of it. So we see that we have a cone here. So there's one cone there. We have a cylinder in the middle, and I'm writing them in different colors just to help out with the separation. And then you see another cone here, and you'll notice that this cone is different lengths from this cone. So I'm going to call this, the one on the right, cone 1, and I'm going to call the one on the left cone 2. Now, since we're finding the surface area of this shape, we need to determine, we need to determine the lateral area for all of these shapes. So we're going to be doing 3 different lateral areas. Now I'm going to go ahead and start off with the cylinder. Okay, so the cylinder, the lateral area for a cylinder, and I'm just going to show you where you can find that. There is a formula sheet that you will be given on the end of course test. Okay, and so this would be the formula sheet that you're given on it. So here we've got a cylinder. Our cylinder would have a lateral area of 2 pi RH. So we need our radius and we need a height. So if we look here at this cylinder is sitting on its side, okay? And if you look here, we have the center point here and the extension here, and it says that that is 2 meters. So our radius for the cylinder will be 2 meters. So R is 2. And our height of our cylinder, since this is on its side, the height would have to be this side here. And you can see that it would be 3 meters. So H is equal to 3. We have R, we have H, so we just plug it in. So the lateral area for this is 2 pi times 2 times the height of 3. 2 times 3 gives you 6. 6 times 2 gives you 12, and you drop down the pi with it. So you get that the lateral area for the cylinder is 12 pi meters squared. Now we're going to look for the cones. Now if you look at the formula sheet, you can tell what your lateral area is. I'm going to start with cone 1. The lateral area of a cone is given by the formula. So the lateral area for a cone is given to you by the formula pi times r times L. And remember, L is the slant length. So let's look at this cone and see if we can determine our radius and slant length. Well, if you look at this cone here, you can easily tell that the base is this circle here, which has a radius of 2. So R is equal to 2. And our slant length L, as we can see here, the slant length would be 4. So we plug that in. Pi times 2 times 4. So we get pi times 2 times 4. 2 times 4 is 8. And then the pi just drops down. So the lateral area of cone 1 is 8 pi meters squared. Then we have to repeat the same process for cone 2 because it's a different type of cone, or a different length of cone. So the lateral area, pi r L. So your radius. Now, you'll notice here this cylinder, the cone sits on the same bases, right? These have the exact same area, radius, everything else. So the radius here is still 2 meters. Okay, so R is still 2, and in this case, our slant length L would be 3. So we just plug that in. Pi times 2 times 3, and we get 6 pi meters squared. Are we done yet? No, we're not. We've just found the lateral areas for all 3 of these shapes, but what we need to do is add them up together to get the entire surface area of this composite shape. So the surface area would be equal to 12 pi plus 8 pi plus 6 pi. So your surface area, 12 plus 8 plus 6 gives you 26. The pi drops down, and your surface area would be 26 pi meters squared. You could also plug in pi into your calculator and get a decimal approximation, but for this one, I'm just going to leave it as pi. All right. All right, so let's look at number 2. Number 2, we're going to find surface area for it as well. Okay, so first we need to identify our shapes that we have. And our shapes for this are a rectangular prism. Now it looks somewhat like a cube, but make sure you pay attention to the side lengths instead. You'll see that they're different. So in here is a rectangular prism. All right. And then here you see a pyramid. And we know it's a pyramid instead of a prism because all of these faces meet at one point. So this is your pyramid. So we're going to find the surface area of the pyramid first. So when you find the surface area of this pyramid, your surface area is given to you by 1/2 slant length times perimeter of the base. So our slant length is easy to get. We see here that we have an arrow pointing directly here, so that slant length is 5 inches. Now the perimeter, remember to find the perimeter of a shape, you have to add up all the sides together, all the side lengths together. So if we look here, this is where our base is. I'm going to outline it in red here. This is our base. So this side here is equal to 3 inches. This side here is also equal to 3 inches. And if you continue along, you'll find that this side is 3 and this side is 3. So your perimeter is going to be 3 plus 3 plus 3 plus 3, which is 12. Now you just plug those in. Surface area is 1/2 times 5 times 12. 5 times 12 is 60. Half of 60 is 30. Oh, that should be lateral area. I apologize. So your lateral area would be 30 inches squared. All right. Now for our rectangular prism, we need to determine the surface area of it. Now, when we do the surface area for this, it's a little bit tricky for the rectangular prism. There is a lateral area formula for it. It's not given to you on your formula sheet. But the rectangular prism's lateral area is simply the perimeter of the base of the rectangular prism times the height of it. Now, because it shares a base with that pyramid, I'm going to use this as our base. Okay, so this side here is going to be our base. So we already know that P is equal to 12. And if we talk about this rectangular prism, if we set it up top on the base, then 8 would be our height. So your lateral area would be equal to 12 times 8, which is 96. However, your lateral area in this case is also going to include, or your surface area is also going to include this area of the base because this one's not joined with anything. So the area of this would be the face there, and that would be 3 times 3, which is 9. So when we take 96 plus 9, we get 105 inches squared. Apologies for the lights. Gotta love automatic. We're not done yet. We have to take these two and add them together to get our surface area. So 30 inches squared plus 105 inches squared gives us 135 inches squared for the surface area of this shape. Okay. And the last one we're going to do, there is a number 4, but we're not going to worry about number 4. So, you know, you can cross out or whatever else. Number 3, we're going to find the volume for this shape. So step 1, identify what shapes that you have. The first one that we see is this triangular prism. And the second that we see is this rectangular prism. Okay. Now we're looking to do volume. Now the volume of a rectangular prism is pretty straightforward. We're going to do that one first. So the volume of a rectangular prism is given to you by the length times the width times the height. So in this case, what is your length, width, and height? Well, if we look here, we see that the length of the rectangular prism is 15 feet. The width is 8, and the height of the prism is 8 as well. So we plug those in. Length times width times height is 15 times 8 times 8. And when you do that, you get 960 feet cubed. So that's the volume of your rectangular prism. Now, to find the area of, or the, excuse me, volume of the triangular prism, it's a bit more complicated. So to determine the volume of a triangular prism, your volume is simply given to you by capital B, H. Now, B is the base area. Remember, for any triangular prism, the base is always the triangle. It is not the rectangle. It is the triangle. Okay? And the H here is the height of the prism, not the height of the triangle. So we're going to go ahead and determine what the height of the prism is first. So if and I'll show you on with these little figures here. If I have a figure like this, and I set it kind of like that, you know, you'll just have to imagine. Now, the bases are these triangles here, right? So if I have it sitting like this, it's not on its base yet, okay? So any of these sides cannot be my height, because as soon as I turn it, those are going to be facing on the ground. So instead, the only side that's going to end up standing up are these sides here, and those are all congruent. So when you stand it up here, this side is your height, and if you look at this picture, what is the height of your triangular prism? And you should see the height of the triangular prism when you turn it on its side would be 15. So your height is 15. And now we need to determine the base area. Now, since we're doing the base area, we have to do the area of a triangle. So big B, our formula for area of a triangle is 1/2 times the base of the triangle times the height of the triangle. So if we look here, I'm going to outline the base. It's this triangle here. That triangle has a base length of 8 feet. So we're going to have 1/2 times 8. And now what is the height of this triangle? Well, this triangle sits on top of the rectangular prism. And we know from here to here is 8. And it tells us that from here to here is 15 feet. So if this part's 8 and the whole thing's 15, what would the height end up being? Well, the height would end up being 15 minus 8, which is 7. So 1/2 times 8 times 7. 8 times 7 is 56. Half of 56 is 28. And then we just plug it in. So volume is going to be equal to 28 times 15, which gives you 420 feet cubed. We're not finished yet. To find the volume of the whole entire thing, we have to add these two volumes together. And that gives us 1,380 feet cubed for our composite shape. Okay. And that's going to be it for this video. There is a worksheet that's 6 problems. All I want you to do is find the volume of those composite shapes. Be careful about the triangular prism ones and the hemisphere ones. There are quite a few of those. Okay, so just make sure you follow these steps, identify your objects, do the volumes for each one, make sure you figure out what the correct base is and what the measurements of it are, and so on and so forth. So that's going to be all, guys. I hope this video helped, and I will see you in the next video.